The certification tests really ask you to take a broad overview of the platform and understand how the pieces and the capabilities provided on the platform can be used to fit together in order to deliver a solution for a customer.
Certification proves that an engineer not only has that real-world experience, but also has the technical knowledge to be able to be certified and to operate at the level that is required.
What certification offers that experience doesn't is peace of mind. I'm not only talking about self-confidence, but also for our customers. Having us certified working on their projects really gives them peace of mind that they're working with a partner who really knows what they're doing.
Great. Welcome, everyone. Thanks for joining us. And today we'll be continuing the installation of 30 Days of Cloud. My name is Matthew Joseph. I am part of I'm the GDSC of the University of California, Santa Cruz. And I think we'll just get straight into it. Cool. So what is 30 Days of Cloud? If this is the first time joining us, 30 Days of Cloud is an event where 16 universities worldwide will be doing a Google Cloud series. And this is for students with no experience in cloud. It's a great way to get some introduction and experience in cloud computing. So some important links that will help you in your journey in this series. First is a cloud coach. Let me take you to it right now. This is the website that is that has the live stream embedded in it right now. As you can see, this is the live stream right here. And I highly recommend registering on this platform. You can get part of this program by registering here and saying which school in GDSC you're part of. There's a leaderboard about us, so on and so forth, all that great stuff. So highly recommend registering here. Next link is the Quick Labs code. This is very important. If this is your first time joining us, go to this Quick Labs right here, as it is on the screen right now. So this is a way to get your monthly subscription to Quick Lab. So you have a month free trial of doing all the Quick Labs and doing as many Quick Labs as you want for a month. So to do so, I'm already logged in, but if this is your first time, the Start Lab might be great. So to fix that, sign into your account, then this Start Lab will become green like this, and you click Start Lab, and the timer will go down. So if you're joining us and doing live with us, recommend pressing Start Lab now, and then let it go on for a couple of minutes. You don't do anything else, and then at the end of the slide, just end it, and you'll get the monthly subscription. So once you get it, like similar to me, you'll get a monthly subscription badge right here. Cool. Next is the Quick Labs that we'll be doing. Right, this is the Quick Labs that we'll be going over today. It is the HTTP load balancer with Cloud Armor. We'll be doing that later in this presentation. And finally, we'll be doing this Quick Lab with you, but let's say you want to continue doing this on your own and you need some help. This is a great space called Kumo Space, where you can go here, join in, and you'll have lobbies which you can go into. Let's just join in this for now. And it's pretty cool. You can walk around and there'll be other people in this lobby, other experts, and you can get your help with. It's pretty cool. You can get your interactions and all that, get your cup of Joe, donuts, whatnot, and you can get help with other experts in this lobby. So highly recommend join this platform as well to get help as you do these Quick Labs. Cool. So what do you get out of this for doing all these Quick Labs? One thing is, if you are looking into a career of cloud, these pathways is a great introduction, and you can get a lot of experience and knowledge for these careers. For example, data engineer, data analyst, cloud DevOps, so on and so forth. There are multiple pathways, which we'll get into later, which is a great introduction as being into these careers. So this is a timeline of events of quick labs that we'll be doing. Today we'll be, like I said earlier, we'll be doing the setup, network, and HTTP load balancers. And this is a great introduction for beginners who, like I said earlier as well, so you don't have to have any experience to do these quick labs. So these are some of the skill badges that you can earn, and these are the pathways. So during these series, we'll be doing these small quick labs. And by the end of this series, you should be pretty much almost there. You just have to do a couple more just to get these skill badges right here. So there's some infrastructure, machine learning, AI, and then hybrid cloud infrastructure. And these are the skill badges that you can earn. So those earlier were like the introduction ones. And once you get those, there are even more skill badges which you can earn, which will build you up in your skills, and you can become even more of an expert. So what is a skill badge? A skill badge is basically like a certificate, I can say, to show that you are learning your Google Cloud skills. So how do you earn a skill badge? As I said, there's a series of quick labs and labs that we'll be going through. Once you do the ones in that series for a specific skill badge, you'll earn it, and you can show it off in a public page where you can show off your skill badges and show off all the things you've learned. So how do you show off these? There's a link right here which you can go to and show off and set up your public profile. And then once you earn the badges, it'll be on your profile, and you can show everyone that you know that you're learning so much about Google Cloud. Great. So as the end of the slide deck, if this is your first time with us, you can end that lab right here, and you should get the monthly subscription. And with that, I'll hand it over to Evan, who will talk about deep learning.
Hello, my name is Evan Hennis, and I'm a Google developer expert in machine learning, and I'm going to talk about using deep learning for basketball, where I use deep learning to predict game outcomes. Here is my Twitter handle, my blog, my GitHub repository. I do have a repo titled blogs, which has all my stuff in it, and this is in a deep learning folder, and my YouTube channel, which is pretty bare, but I do have one, so I figured I'd share it. So a little bit about me. I got my undergrad from Iowa State in 2004, and then I went and worked for a small software shop for a while. I decided I wanted to go back to school and my master's, and I did that with Georgia Tech, and I used their online master's program. So I know a lot of you guys are students. If you want to go a master's but you still want to work, I would definitely look into that. It was well worth it, and most companies will pay for it. My day job is a C# developer. I've been doing that since 2004. After grad school, I got more into machine learning, and that's when I became a GDE, was in 2019. Here's a quick shot of my family. This was, yikes, 6 years ago, because that little baby is now 6, running around like a crazy person. So a quick overview. I'm going to talk about the project introduction, then discuss the data collection. I'll move on to the actual building of the model and the training, testing, and all of that stuff. And my final 2 parts will be actually deploying the model. So you can take your trained model and then put it out so users can actually get to it. I've seen a lot of demos that kind of ignore the last part. They let you create your model in a collab notebook, and then that's it. Well, you can't have someone come to your collab notebook. So I decided to add the part about doing deployments, and I am going to talk on Tensorflow Js for the web and Tensorflow Lite for mobile. So my introduction, I wanted to put my master's degree to use on an actual project after I was done with school, because I wanted to prove that I could do it. And like a lot of you will get into, when you graduate, they want you to have experience to get a job, but you have to get a job to get experience. So I want to do something on my own that proves I could do it, much like the quick labs that was discussed earlier. Just proves you can do it. I also was lucky that gambling became legal in Iowa, and that's where I live about the same time. And I just want to see what I wanted to do. So the technologies were TensorFlow. And at the point when I did this, V2 had just came out, and the collab notebooks actually had to like put a command to do V2. And now it's built in. Everything I did on the data science side It was all in a Google Cloud notebook. I did nothing on my local machine. And then HTML for the web, and then Android and TensorFlow Lite for the machine learning part. So I know it's a Google group, but Facebook has a really nice guide to machine learning. They do a pretty good job of pushing out what they do, their best practices, things like that. So I built my model around this, and the guide's broken down to your goal definition, getting your data gathering, parsing the data, your model creation, and then accuracy. It's important in data science to have this written down beforehand, because there's chances that your model is not as good as you like, and instead of trying to figure out why, you bring the goalpost a little closer and you say, well, this is what I really wanted. So having these down ahead of time is very important. So defining my goal, what am I trying to do? So it's pretty straightforward. I want to predict the outcome of a basketball game. And then I need to define what is successful. So to be successful gambling, you need to win, I believe, 56% of the time, because you've got the VIG, if you will, that Vegas takes. So you can't just win 50% because you'll lose money. You need 60. So that was my goal. And plus or minus 5 points. I'm never going to be able to predict all the games accurately, but if I can get within 5 points, I can decide who I want to pick. If I think a team's going to win by 20 and the spread is 10, that's obviously a nice margin. I'm going to go that way. So those are my two success criteria. So data gathering, getting data is always an issue. For me, all of my stuff was pretty straightforward when I wanted to collect. I was able to use ESPN.com and NCAA.com. And knowing that those are public websites, I don't want to DOS attack them with my testing. So when you're collecting data, if you're doing something in the public domain, download the data and cache it. Don't keep hitting their website. A lot of sites will detect it and kick you out. So go get your site, download that page, and then test off of your local data. Don't be a jerk, I guess, when you're out doing there. For the data that I wanted the game results. I had to grab all the teams. I wanted to grab the conference they were in, and when available, I wanted to get the spreads. Now, if I started this today, every game has spreads on it. 10 years ago, when I was grabbing data from, they didn't have spreads. So a lot of this stuff is harder. I couldn't use the spread in my training of the old data. So the spreads I collected was just for personal validation, didn't really go into the model training. As I said, I am a .NET developer by trade, so it was easier for me to write a .NET app to go and grab the data and bring it in. Ideally, you'd stay in Python, which is the rest of your code. I also have a couple R scripts that does a fantastic job of parsing HTML data. So if you want to get into R, that's a good way, little side shoot of using R to grab the data. But I did C# because that's my primary language. Data parsing, you have to clean the data. The biggest issue I had was making sure the teams were legitimate. So is St. John's, St. John's, St. period John's, State John? I had to go through and basically find and replace all of my data. If I saw it spelled this way, this is my source of truth. This is the real name. So that was a big issue I had, keeping the names consistent. If you know a lot about basketball, these next two make sense. I want to make sure it's all D1 teams. For me, I didn't care if Iowa State played a local small school because they're not comparative. It doesn't add any value to my training, so I dumped those out. And the other is move canceled games. A couple of years ago, one of the tournaments was canceled. It shows up as a no result. That doesn't add value. I got to wipe those. And then if you've done any of these labs on deep learning, you always normalize the data. It's one of the first things they have you do. It just keeps the scores going up to 90, not taking away from maybe other values that are 1 to 10. You would normalize those so they all kind of have their same weight. So model creation. And if you flash back to the Facebook page, the first thing you should do is make a very simple model. the simplest model for me is flipping a coin, heads or tails, 50%. I've got to beat that. Then you slowly start adding stuff, and then adding stuff and adding stuff. And you kind of iteratively build your model until you get to where you want it. For me, I'm going to do a neural network. It was the hot new thing. People were all over about it, and it was pretty easy to go. And it fit with my requirements. The downside is you need a lot of data for a neural network, and you can overfit if you train too much, if that makes sense. It will learn your data really, really well. I had 10 years of games, and there are 112 teams, and each of those teams plays 30 games. So I had quite a few games. So I had some leeway there. So I didn't have a problem with data. If I would start adding more input parameters, I would need to consider, do I have enough data to do all of this? If I'm training on the home team scoring the first 5 minutes, do I have enough data to justify that? And things, that's a dumb example, but things like that. And then with neural networks, you just iterate through all your hyperparameters. Does your model need more layers, less layers? How many nodes you want per layer? What kind of optimizers? Things like that. And again, it's just trial and error. I set up my collab, I'd run a test, come back. Okay, did I get better or worse results? Okay, where do I need to adjust from there? As an example, I will show some code. Again, all this is done in a Google Colab, and that's why it looks like this. For me, I learned on TensorFlow and Keras. There's similar stuff if you want to use PyTorch. That's kind of big in academics, but again, I started with Google and I kept with it. So this is my Keras model. I decided on just 2 layers, 32 nodes, then the Raylo activation. And then my input shape, if you guys have never seen this before, that's how many parameters I pass in. In this case, I did the home team's scoring at home, the home team's scoring given up at home, the away team scoring away, and the away team giving up points away. So those are my 4 inputs. I passed those in, ran through this model, and then I got my values back out. And again, all of these things can be changed. It really is an art. There's not a great way to go, oh, I see this, this, and this. That means I need to use this optimizer. I need to use this activation layer, things like that. So it is trial and error, kind of dig into what each one does, and what fits your requirements. Accuracy testing. For me, I was lucky. It's pretty straightforward. I passed in numbers and I got out a number. I then compared those to the real number. If I thought the home team would win by 10 and they win by 5, it's within my 5 margin of error. But again, during training, it tries to narrow those down. Harder models, you do have to worry about area under curve and things like that. And the example I give here is in a place like Facebook or Google search. If you would train whether someone's going to click on an ad, it's going to be no 99% of the time. So you can't train a model to do that and just go right or wrong. Because you just say no, you get 99% accuracy. That's unreal. So you need to figure out, you can't just use a straightforward accuracy number like I did. That's why I was able to do what I did and made it really easy. So I didn't really cheat, but it was nice to have that available. So after I created the model in the Google Colab notebook, I did my training and testing and validation. Everything was good. I liked my results. My next step is actually pushing the code to the world so they can test it. And for me, the web deployment, I use Tensorflow Js, and it makes a file for you. You put it in, you load it just like a JS file, and you get the same results. TensorFlow does a fantastic job, one with documentation and one with their conversion tools. So if you have any questions about this, TensorFlow's website is fantastic, but it's straightforward and simple. You import your library, you have your existing model, you save the model, you convert it, and then the last command is download. I now have my model to deploy on the web. And it's really not, I'm not training in the web, so what I need in the actual HTML code is extremely limited. It's straightforward. You're basically passing numbers, and the JS file does some math and spits it back out to you. the next, and I've got the website later. If I've got a couple minutes to spare, I'll walk through what that looks like. For my Android development, I use TensorFlow Lite. This is fairly new, but it's kind of how they're going for smaller devices. I think I'm giving a talk next week on a Raspberry Pi. I use TensorFlow Lite model on that, and it's fantastic. It's pretty simple. Again, in Google Colab, I imported the converter, I converted it, and I saved it off the TF Lite file, and it works. And there are some Gradle stuff you have to do. I can show that later, and it's well documented, so you won't have a problem if you get to that. Future projects, what I'm doing, again, I got to finish my Android app. I haven't published it. The other thing is trying other models. When I went back, I decided on a neural network, but truly, I need to use other model types to make sure that the neural network was actually want. XGBoost is the hot thing right now that everyone's trying to do. I need to go back and see if I get better results, things like that. And again, test, do as much as you can. It's really just trial and error. There's always for the duration of my project, I was always trying to think as a basketball coach. What do I want to defend against? What do I want my offense to do? And try and find a way to model those numbers and then put that into my neural network. So all of that, it's kind of a living thing where you just keep making changes until where you think it's, that's perfect. That's where I want to be. So my conclusion, my goal definition, beat Vegas, get that 60%, start making money. Data gathering, again, I grab from the internet. Data parsing, I mentioned cleaning the games and the teams and everything like that. Model creation, I did my own network with TensorFlow. And then accuracy testing, I compared it against the actual scores. So here's my information, everything I listed before. I do have a project about this with Manning. You guys have questions, let me know, not a big deal. So I'm going to, I think I've got about 3 minutes here. I'm going to show you my Android first, because that one's a lot cooler. So TensorFlow Lite has what they call an interpreter. So when I go into my manager, I call this interpreter, which is from the TensorFlow.Lite.interpreter class. This takes in an input array, and it spits out an array of floats. And that gives me my result back. So really, a neural network is just a really nice math equation. This interpreter accepts that. Okay, here's numbers, pass it in, do the math, come back in, here's your results. So for my Android app, get this fired up here. I can set conference. Again, if you guys don't know basketball, it probably makes no sense, but just for giggles. So this tells me what I think the spread's going to be. Okay, and what I'm doing here is I'm taking all of my data. I've got all the stats for all my teams. I pass it into the network and I spit it back out. And again, it's really as simple as creating an interpreter, passing your values in, and getting them back out. So it's super easy to make this work on Android. And now I will show you the web version. It's a little different. The TensorFlow app, TS scripts. If you look at model.json, this is my model. That's all I need, all the work, and it spits it out like this. So all this application is doing is calling a reference to that file. The TF Tensorflow Js converts it to your model object. For your model object, you pass in your input values, and you get your prediction back. So again, once all the heavy lifting is done in Google Colab, convert it to either Lite or JS file, and then you predict like that. And all of a sudden, my website now has machine learning on it. And same as before, conference teams get prediction, and you get the values back. So that's kind of an overview. I didn't go too much into the actual building. There are some really nice pre-existing models if you want to do something like that. If you want to train your own, get in touch with me. I can show you. But there's also quick labs that do this. I've done quite a few of them. So that is pretty much it for my presentation. Is there any questions? I'll stop my sharing here. If not, any questions? Nope. So I will now pass this to Chetan, and he is going to do your lab walkthrough.
Hey everyone, I'm the GDSA lead from the University of Ottawa, and I'm going to be going through the HTTP load balancer with Cloud Armor Lab. The link to access this should be somewhere in the description or in the chat. And yeah, we'll just get started right here. Oh, there it is. So when you press Start Lab right here, you'll get prompted to first do some sort of CAPTCHA. And then you have to use your subscription. And I'm assuming you already have the monthly subscription activated from what Matthew talked about earlier. So you just pressed use and here we go. So what I do right here is I'd open in a new window just so it's easier to look at the lab. I'm going to do an incognito window for myself and sign in with these credentials. So copy that. Here we go. So yeah, we just went through the setup section. And we'll get started with the first section, which is configuring the HTTP and health check with firewall rules. So first instruction, you go to the navigation menu. Feel free to let me know if you want me to slow down or if you have any more questions that you want to ask. But from here, you go to the VPC network and firewall. So we notice these existing ones, and then we create a new firewall rule. To that, we're going to use all the properties here, so you can just copy and paste them. Network is default. Targets tag. And IP ranges. You can use IPv4 or 6, it doesn't really matter. And the range is going to be 0. And for specified ports and protocols, make sure to include a 0 there. And the source IP ranges, yeah, I have that. And we'll create. I think I missed something. So yeah, in the TCP section, we're going to have to add port 80. Should be good. Okay. So next one, we're going to create another firewall rule. Create it. And that one's going to be to allow our health checks. And so the network is default like last time too. And the targets will be the same as before to just HTTP. We're not using HTTPS. So IPv4 again. And for the tags, for the ranges, we're going to have 2 this time. So all of these we add. And we're going to check TCP, not going to have any specific ports, and click create again. So at this point, I should be able to check my progress. Yeah, right. Okay, so next part, we're going to be creating an instance template. And for that, I'm going to go through the navigation menu to Compute Engine and Instance Templates. We're going to create an instance template, and let's see. So name is going to be US series of N1. And that's about it. Just so we get to the management section. Under the metadata, we're going to have to add a script, and the script link is provided in the instructions. And then go to networking, where we'll be making the default network with the US East 1 subnet and HTTP server. Create. And then we're going to create another instance template for subnet B by copying this one. So we do that is click on this. And we should be able to copy it. Here we go, create similar. And we're going to make one for Europe. And same as before, go to management. And in there, we'll go to networking and create another subnet for Europe. So Europe West 1. And create. Seems I'm missing something. So must be lowercase, add a period. Here we go. Create. Perfect. So the next one, we're going to go and create a managed instance group in US East and Europe West 1. So I'm going to move on to that. That will be done in instance groups. In this menu. Still in Compute Engine. Instance groups. Feel free to drop in the chat if you have any questions, if you want me to go back to anything. So I'm going to be doing everything again to the values that they say. So make this a migration for US East with multiple zones with US East 1. And for instance template, we're going to create select the one that we created before. And CPU utilization, we're going to make this 80%. Click done. So number of cooldown period is just 45 seconds for just 5 instances. So we'll create that one too. Perfect. And while that's creating, I should be able to just start off with the one for Europe. So I'll create an instance group again. Europe West for title, multiple zones. with the request one. And the template, we're going to use the one we created before for your request one with CPU utilization, same as before, 80%. And cooldown period for 45, 1, and 5 instances. So I'm going to create this with no errors, hopefully. And I can check my progress, but I probably have to wait for these to be created. Okay, one of them's done, the other one 100% finished. Oh, seems that it finished. So we're going to move on to the next part, which is we're going to verify the backends with VM instances. And we're just going to open up what we made to make sure that they're still running. So we can open up this link. Or I don't know where it opened up, but I'll open up here. This one does not connect. Weird. But this one should. There we go, with our host address, migration, and for US East 1. So yeah, you can see that what we made works, and we'll answer this question, which is which of these fields verify the region of the backend. It's going to be, I believe, the host name and server location. Perfect. Sweet. So I'm done my part of my lab, and I'm going to pass it on to Matthew to do the rest.
Welcome, everyone. Thank you, Chetan, for the great preview. And then now I'll be continuing on with the lab. So I'll be sharing my screen, and then I'll continue on. So picking up where we left off, so configure the HTTP load balancer. We'll start with the configuration. So we'll click the navigation menu, click network services. Let's go down here. One thing I've always had trouble is finding the name. So many things to do that finding is a bit hard, but great, found it. Load balancing right here. And create load balancer here. And then now under HTTPS load balancing, start configuration. And then from my internet to my VMs, continue. Set the name to HTTP/LB. Then let's go to create backend configuration. So we'll be doing that from backend, create backend servers. Okay, great. So now, like before, we'll just copy this over and see instance group. Okay. Next one, migration, port numbers is 80. Bouncing mode rate. Okay, and then maximum RPS is 50. Capacity is 100. Okay. So just on wondering why we're doing certain things, this configuration, as it says right here, is a backend load balancer will try to keep each instance of the virtual machines, which, oh, by the way, VM means virtual machine. So each VM to below 50 requests per second. So that's where the load balancer goes. It tries to balance all the VMs so it's not, each are not over, don't have too much load. Then we'll create another backend. So instance group is the Europe one. We just did the US East, not the Europe West. Port number is 80. Now utilization, now right before, last time we did rate, and we'll do utilization. Backend is 80, capacity is 100. Okay. So the difference between the East, US East and Europe West is now the Europe West is, rather than keeping 50 requests per second, now it's going to do 80% CPU utilization. Click done. I think I clicked that earlier anyways. And then for health check, let's go down to here, create a health check. Like I said, right here. And then let's copy over these info here. So this is the name, protocol TCP, port ID. Awesome, already filled in. Okay. Yeah, so as description here, waits up to 5 seconds for a response and treats 2 successful or 2 failed attempts as a healthy or unhealthy. I think this is good for as logs. So as a developer, you can see, okay, are certain servers healthy or unhealthy? And you can look into it if your certain VMs are healthy or unhealthy, as I said before. Now we'll click into save and enable logging, which is very important as a developer for any future projects. Logging is really useful, so you can see what you're doing. And then do create. Awesome. Okay, now that is done. Let's go to the configure front end right here. Specify the following, leave again. So protocol is HTTP, IP version is IPv4, IP address formal 80. Awesome, it was already done. Okay. And then click add IPv4, HTTP, instead of IP4, then IPv6. For sure, this is, you can keep it premium. I think that's fine. IP formal and then 80. Cool. And then click done. And then review and finalize. Let's double check everything is good. So here, let me make this a little bit wider. Premium here. I think my front end, I have epipheral. Let me fix that. I think that's wrong. Let's do that right here. Is that it? IP address epipheral. Okay. I think that's fine. I think. Yeah. Epipheral. Unmatched here. It should be 30 seconds, so on and so forth. So CPU, all this is right here. Selected ports, capacity 100%. Okay, cool. Should be good. Let's do create. Let it load up. Let's see if check my progress, but I think I might need to wait. Yeah, let's wait for this to load up and then let's click check my progress. See if I did anything right or wrong. Well, wait, if you have any questions, please feel free to drop in the chat. I'd love to answer any questions as we go on through here. So, can check our progress now. Okay, awesome. I think we'll just go on with it. Still taking some time to load up. So I already did this lab, but the HTTP load balancer should forward traffic to the region that is closer to you. Okay, great. It just loaded up. Awesome. But yes, this question is true because that's ideally what you want to do as a load balancer. And yeah, I think there's one thing here. So no, the IPv4 and IPv6 addresses for load balancer for the next task, they'll be referred as IPv4. Okay, great. Click on the name. Okay, I almost skipped over that thing. Let's save it. So I believe it's these ports right here. So one thing which is good to do is let's do a keep.google.com. So let's notes, as it says, let's keep note of that. Okay, so notes is IPv4. What was it? I think it's this one right here. And then the 6. This one right here. Close. Let's go back to this. So we save that right here. I believe that's the right IP address. We'll see if I'm wrong. Anyways. Tesla, let's open a new tab and then go to this. So let's copy this over. And let's go to HTTP. Is that wrong? Okay. Something. I don't know, it might take to 5 minutes. So yeah, okay, that's right. As it says, might get an error. So let's just refresh a couple of times while we wait. No. Not cooperating with me, unfortunately. I think this is the right port. I don't see. Let me try this one. There you go. Amazing. Okay. As it says, it'll migrate me. So I am near close to the US East one. So that's why it routed me to here. Awesome. Kind of scared me a little bit right there. All right. Let's go to now. Let's stress test the HTTP load balancer to make sure. Let's actually test or make sure our load balancer actually works. So let's go to navigation compute engine right here. And then VM instance all the way on the top. Let's go right here. Let it load for a second. I should play the Jeopardy music in the background. Okay. Anything I need to do. This VM instance is not showing up for me. Okay, there you go. Create instance. That was not showing up for me. I'm not sure why, but nevertheless, we are here. Okay, create instance. And let's let it load. Okay, and let's copy over the things. I think I'll just type it in instead. Siege-VM. As a reminder, VM stands for virtual machine. Region is now US West 1, slow carbon emissions, that's cool. And then zone is US West 1C. Okay, cool. Series is N1. I think that's all the information we need to do. And then create. Let's wait for the VM Siege to open up as it's saying. For the Siege, so let's wait for it to load up. Computer's a bit slow with me, but that's okay. All right. Still waiting. Again, if any of you guys have any questions, please feel free to drop in the chat. Love to answer any questions. Awesome. Okay. Let's go here. And then let's click SSH. I think I forgot to say into here, but for you guys watching the live stream, click on Siege VM to go to click SSH right here. Okay, awesome. So this will show up a terminal. So let's connect. Yes, please. So a connection. So this is the command we want to do. Let's paste it right here. So okay, installing all that. Awesome. And then remember, like the commands that we saved earlier, we want to put that in here. So instead of this placeholder right here, we want to do the IPv4. Let's do that. Okay, and C. And let's run that. And let's copy this command right here. Great. The server is under siege. Awesome. Okay. So now let's go back to here. Don't close this, please. Keep it open. And then let me move this over so I can see it properly. Navigation menu. Let's click on to network services. I think that's a little bit down here. Network services, and then load balancing. Let's click backends right here. And click HTTP backend. Okay, so this is the monitoring here. Last time this did it, it took a couple of seconds for it to refresh. So let's wait for a couple of seconds for it to refresh. Let's see if I can refresh this website. But I really like this graphic. Hopefully we can get a similar graphic right here, where it shows where the load balancing is working. Almost done with the lab. Sticking with us. Thanks for sticking with us. And again, any questions, feel free to drop in the chat. Still working. Yep. Still working. Waiting for a couple of minutes. Ah, there you go. Beautiful. Okay. So as you can see right here that that's a request per second right here. And then as you can tell, this server right here is the east one. So it's loading all of that to the east server here, and only a little bit to the Europe west. Amazing. Okay. Love to see that. Right. Now we can return to the SSH terminal here. If you haven't done this before, if you want to cancel a program like a force quit, like a computer, like a force power up, just do Control-C as it says. Awesome. It ends. This is some logging information right here. All right, cool. So denials of a siege VM. Let's go to that section now. So let's go to navigation menu, compute engine, and VM instances. Okay. So note the external IP address of the siege VM, which is this second row right here. So like before, I think let's save this right here. So let's go to here. Let's save right there so we can reference it in the future. The cal console. Okay, so now that there was just copying the IP address. Let's go to network security. It's down here. There it is. Here. Network security and cloud armor. Okay, under the networking section there. And then we'll create a policy right here. And the name is, let's copy here. So denialist siege. And then default action is allow. Okay. Next up, you want to add rule. Okay. Condition is a siege IP. So I believe you just put it right into here. I think I still have it saved. Oh no, I don't have it saved. So this is important to save the IP address. Let's go to here. Let's go to here. Awesome. Save it. And right here. Okay. So if we click out of this, 403, priority is 1000. Okay. I think it's, yeah, I think it is just that. All right. 403 forbidden, so on and so forth. Okay, click done. And then, yeah, as it said right there, I should have scrolled a little bit down, but yes, that is what we had earlier. Okay. Now click next step, add target. For type, click load balance to backend service. For target, HTTP backend. Awesome. Okay. And that was at the target here. There was a slight error there on, it was saying that there's no target, but now there is a target. Target is that. Okay. Now create policy. Okay. Let it load. Let's see if it'll check my progress or not. Sometimes it lets me. Awesome. Okay, cool. There you go. Awesome, awesome, awesome. All right. So return to SSH of the siege VM. So hopefully you guys didn't close that. Should have said that earlier. Let's copy this. So last time I did this, it took me a couple of seconds to, as it says, a couple of seconds for the security to work. So right now, what we should see is as we try to access the HTTP for the server, it'll deny. So right now it is fine. Let's see if I can do this. It's fine. Give it a couple of times to put up. And just for reference, how I'm able to pull up the last command is the up and down arrow keys in here. So it can show up the last command. So I can go up to previous commands like this, so on and so forth. Here. Still allow me. Let's keep on waiting. While we wait, if anyone has any questions, comments, concerns, please feel free to drop in the chat. While we wait, I'm more than happy to answer any questions. Still waiting. Oh, I did just complete the assessment, so should be good. I don't think I should have done anything wrong. A couple of minutes for it to. Still waiting. Still waiting. I think in the meantime, let me just show a couple of things. So in terms of priority, the lower the priority, it's a bit counterintuitive, but the lower the priority, the more higher it is. So that's why I was a bit concerned earlier before doing this. But it'll deny, this is the top rule, it almost as if you can, in terms of importance, this is the higher importance, and then this is, so first deny this current server, and then it'll allow others. I think while we wait, still allowing me. I think just as a reminder, the importance of this lab is to balance off the servers. So once you are, so you don't want to overwhelm each server or individual server. You want to balance it out into the multiple instances. So you can see So each server can work, how can I say this, like can be managed efficiently. So you don't have a certain server at 100 CPU and being overworked while others are casually working on like 10% CPU utilization. And with that, I'm happy to say that now we are currently denied, as it says here, 403 forbidden. Awesome. As some in previous editions, the 403 is a bad thing, but now it is a good thing because it shows our code works. Okay. So open a new tab and let's go to the HTTP / don't forget the / and it wants to go to IPv4. So let me copy it from here. See, so this, the purpose of going to this lab, to this IP address is showing the rules that we said earlier, right? So, yeah. So in terms of importance, our siege server is being denied, but since we said all other IP addresses, this other IP address is being allowed to go through. So it shows that everything else is working. Awesome. So let's simulate the siege one more time, like this. Siege is under, the server is now under siege. Cool. Console, navigate to navigation menu. Okay, so we're going to a different location. So underneath the navigation, networking, we go to network security, cloud armor, back to here. Click on the denial of siege. Click on logs, view policy logs. So this looks a bit overwhelming, but just follow through with us and I'm sure you'll be able to understand. So on the logging page, make sure to clear all the text in the query preview. To do so, click on the resource HTTP cloud balancer. Where is that? No, click on HTTP load balancer. HTTP forwarding rule. HTTP LB. And then click add. Where is add? It's like Blue's Clues trying to find add where you guys might see it, but I don't. Where is add? Let's make sure I'm reading this correctly. Click on select. So I did select the HTTP load balancer, HTTP forward load, and then forwarding rule, and that, and then I think it should be fine. Is it just covering it? No, that's not covering it. Then let's just do run query. Okay. I think that was fine. So expand the log. Expand a log entry in query results. Okay, let's expand one of them. And then let's expand HTTP request right here. And then expand JSON payload. Okay. Expand enforce security policy. And then notice the configuration action deny is the name denies. So like I said, configuration action is deny, and then the name is from the denial siege VM. So this is another thing where the logging was very important before. That allows us to see all of this. Cool. Okay. I think with that, we are done with this quick lab. Thank you for joining us and joining me and Chetan on this quick lab. We had some up and downs, but nevertheless, we are done with it. So I just want to remind everyone, you do have the monthly subscription. So please utilize this. Quick Labs is a great resource to use. There's a lot of information to learn, as I hope you saw in this. So please look into all the other Quick Labs here, any of the series here that you can do to earn badges. So you can continue on the quest right here. There's also other labs that they're recommending. So to continue and get your skill badge. Please, like I said, oh, sorry, no, my screen wasn't sharing, but this is another lab. If you really like this one, you can start the next one. We do have these events in the future, so I'd love to see you guys in the future events. And thank you so much for joining us.
Hi, welcome to You Have Data, but what are you going to do with it? I'm Evan, a technical curriculum developer here at Google. And in this module, you learn how you can gain insight through data using managed big data services. So far in this Google Cloud Computing Foundation course, you've discussed what cloud computing is, the Google Cloud Platform, and using GCP to build apps. You then explored storage options, the role of APIs, cloud security, networking, and the role GCP can play in automating the creation and management of your GCP resources. In this module, you look at some of the managed services that Google offers to process your big data. The objective of this module is for you to discover a variety of managed big data services in the cloud. The specific learning objectives to achieve this include you being able to discuss big data managed services available in the cloud, describe the use of Cloud Dataproc to run Spark, Hive, Pig, and MapReduce as a managed service, explain the building of extract, transform, and load pipelines using Cloud Dataflow, and discuss BigQuery as a managed data warehouse and analytics engine. This agenda shows the topics that make up the module. The module starts with an introduction to big data managed services in the cloud, before moving on to how big data operations can be leveraged through Cloud Dataproc. You'll then complete 2 labs where you use the GCP console and then the gcloud command line tool to create a Cloud Dataproc cluster and perform various tasks. After the labs, you'll explore the use of Cloud Dataflow to perform extract, transform, and load operations. The next 2 labs provide an opportunity to learn more about Cloud Dataflow. In the first, you'll create a streaming pipeline using a Cloud Dataflow template. And in the second, you'll set up a Python development environment, get the Cloud Dataflow SDK for Python, and run an example pipeline using the GCP console. In the final topic, you learn about the role of BigQuery as a data warehouse. You'll complete the module with a short quiz and a review of the main learning points of the module.